The previous module looked at the process of determining the most appropriate initial lens from the diagnostic set for each corneal type. This module will look at the behaviour of the lens on eye and how this can be used to assess the fit of the lens. When the chosen KeraSoft IC lens is placed on eye, the fitting assessment should start within the first 5 minutes. This enables the practitioner to distinguish between a poorly fitting lens and an optimal fit quickly. The overall best fit is determined by assessing 5 key characteristics of lens performance. These are movement, rotation, centration, comfort, and visual acuity. These are the key building blocks that determine the KeraSoft IC lens fit and are easily remembered by the acronym Morocco VA. Each of these form an integral part of the complete fit, and therefore they must be assessed together. It is crucial that the diagnostic lens displays these optimal fitting characteristics to ensure that the ordered powered lens behaves in the same way. The first 3 of these building blocks, movement, rotation and centration, are assessed on the slit lamp within 5 minutes of the lens being inserted. These are assessed using the dynamic assessment routine. The movement, rotation and centration of the lens are assessed while the patient blinks, first on straight ahead and then on upward gaze. The lag of the lens is then assessed during lateral eye movements, or what is termed excursions. We will now look at the movement, rotation and centration of an optimal, tight and flat-fitting lens using the dynamic assessment routine. First, let us look at movement. The KeraSoft IC lens will move more than other soft lenses post-blink. This is an optimal fit on straight-ahead gaze. The post-blink movement of an optimally fitting lens is 1 to 2 mm. Up to 2 mm of post-blink movement is acceptable as long as the patient is comfortable and the other fitting characteristics are found to be optimal. On upward gaze, the movement is typically more compared to the straight-ahead gaze. This is due to the lens-lid interaction. On lateral excursions, there will be a small amount of lag. Let's compare this to a tight-fitting lens. Here the post-blink movement is less than 1 mm on straight-ahead gaze. A very tight lens may exhibit no movement at all. On upward gaze, the lens may move up to 2 mm due to lid interaction. But on excursions, you would expect to see limited movement. In cases where the lens fit is very tight, it may not settle easily after insertion and will move excessively. This can occur at any point within the settling period. It would be easy to mistake this lens as a very flat fit based on movement alone. However, as with all cases, it is important to consider all fitting characteristics before determining the actual fit of the lens. Up to 2 mm of vertical movement is acceptable as long as the patient is comfortable. However, movement of more than 2 mm indicates a flat fit. On upward gaze, the lens moves excessively. And on excursions, the lens will drift with the eye movement. In cases where the lens is very flat, it may decenter and become immobile, thus mimicking a tight-fitting lens. This can happen at any point within the settling time period. Again, care must be taken not to mistake this as a tight fit. We have looked at movement, now let us go on to rotation. For an optimal fit, the laser mark should be as near to the 6 o'clock position as possible. The position of the laser mark will remain at 6 o'clock throughout the blink cycle, in the straight ahead position and upward gaze. If the lens rotates by more than 10 degrees in the straight ahead position, it indicates that the lens is not fitting correctly. This could be a flat-fitting lens or a tight-fitting lens. To differentiate between the two, observe whether the rotation of the laser mark is stable or unstable when the patient blinks. A tightly fitting lens will show limited swing of the laser mark on blinking. On upward gaze, the lens will stay in its rotated position. For a flat lens, the laser mark will swing erratically as the patient blinks. On upward gaze, the laser mark will swing significantly, usually ending up in the 6 o'clock position. Now, centration. The lens should be well centered. The front optic zone of the lens can be used as an accurate guide as to where the lens is sitting on eye. An optimal fitting lens should sit centrally. Allow a minimal amount of decentration if the other fitting characteristics are optimal. On upward gaze, the lens should remain centered during blinking. A tightly fitting lens will be central in a straight ahead position and in upward gaze, so other fitting characteristics such as rotation will need to be used to distinguish the fit here. In straight ahead gaze, a flat fitting lens may be decentered. On upward gaze, the front optic zone may fall to the limbus or below. If this does not reduce as the lens settles, then this is a clear indicator of a flat fitting lens. The results of the dynamic assessment routine regarding movement, rotation and centration will be combined with the comfort and vision results to determine the overall lens fit. In the next module, we will see how to bring these 5 characteristics together.